Okay, then let's now take a look to a nightmare on Cube Street.
Right, hello, everybody. I'm Dave. You already know Surya from the previous talk. We're going to be talking to you about VPCs, or in other words, a nightmare on Kube, slicing Kubernetes networks. Right, VPCs. Who knows what a VPC is? Show of hands. Ben does. Right. So cloud providers have had these for a very long time. Virtual private clouds is one way of defining it, I suppose. You could imagine it as a container, but for everything networking. So for all of the logical constructs that we have, so switches, routers, networks, subnets, firewalls, everything, the ability to have those contained is basically what we're looking for and what customers are asking us to try and provide to them. I asked AI to generate an image. It's done a fairly good job of putting networking in the containers. I have no idea why we have a sandwich or why the bread on the sandwich is toasted. That just seems a little bit weird to me. And don't ask me what type of network connector that is either. The other way that VPCs are used is as an administrative boundary. So the idea being that customers should be able to self-serve within one of these VPCs, so they can create as many networks as they like, they can create their own firewall rules, they can basically do whatever they like without affecting any other tenants. So there are a whole bunch of things that go into VPCs. I've talked about these a little bit, and this is my magical rubric of what do we mean if we're in this cloud over here? How do we take that then from a cloud environment to something bare metal-y, and what does that mean inside of OVN Kubernetes, which is really the way that we try and deliver this to people through OVN Kubernetes, down through OVN, through OVS, and eventually in a way that it's intelligible. So we touched a little bit on user-defined networks. That is basically our subnet construct. It's a single network where you can deploy workloads into. We already have security groups through network policy, but there's a couple of little gaps in this rubric where we're not entirely sure what the primitives are that we should be that we need to be able to make this concept work. So I will pass it on to Surya, and maybe she has some answers.
That wasn't 4 minutes, Dave.
Of course it was.
Okay, so I'll actually take this a level deeper and show you how we did this in OVN Kubernetes, and I will go deeper into what a UDN is. We got some questions on what that network looked like in the previous talk. Maybe this talk should have been before the previous talk, but let me touch a little bit deeper into what Dave was mentioning about a subnet. So everybody knows what a subnet is, a CIDR block. We think that the VPC modeling, in a VPC modeling, we can somehow parallelize a subnet concept with what we have in UDNs, which currently is one subnet that you see right here. So I think you are already familiar with the API now. I showed you in the previous presentation. It's basically just calling out the subnet that you have that is allocated to this network, and this is the subnet from which each pod gets an IP, a pod or a workload, right? And then to answer your question before, like there are different types of networks. So you have this layer 3 network, a layer 2 network, or a local net, and different types of how this is then translated in the OVN layer. I'll show you how that looks like. So for a layer 3, each host gets its own slice from which the pods get an IP from. A layer 2 is a flat network across all nodes. And then a local net is where the pods are able to directly talk to your provider network with no SNATing, etc. So basically, a UDN lets you configure different plug-and-play types of networks that are translated into interesting topologies in OVN. And this, I know, is like a bit more abstract than, no, that's a lot more than a subnet. That's true. But for the VPC world, we can think of this as a subnet, and there's an OCAP in our community where we're trying to expand this to be more than one CIDR. So multiple CIDRs could also be a part of UDN, or it may not land, right? We don't know the status of the OCAP yet. The overall picture of how this looks like, so in the end of the day, each user can get their own network segment that you see on the left side. In OVN Kubernetes, we use Geneva encapsulation tunnels for east-west. And for north-south that I mentioned, it's going via the OVS bridges to the outside. And that's how it looks like on an OVN layer. So now this must be a bit more familiar with switches and routers. So if you have a blue network, a green network, and a yellow network, the yellow network that you see on the top is a layer 2, where it's just one switch spanning across all the nodes. And then the layer 3, you see a router that's routing between the nodes, right? So if you see these on the OVN layer, there's another, and then now this is what gives you the isolation, right? So on the OVS layer, you have this native isolation where you have basically you drop the traffic if you try, because there's no routers routing it between the networks. And then we are introducing in OVN Kubernetes another new feature called Cluster Network Connect that builds on top of the UDNs. So you could say this is a group of connected subnets. So if somebody wanted to now connect to such networks, Berlin and Munich, with OVN, it's so much easy because you can just put a router in the middle, and that's exactly what we did. So it's not a big feature. It's really just the API looks complex here, right? Because now you have to select all the networks that you want to group together, and you also want to give a connect subnet on top, which is what is going to allow you to connect those networks together. So this is a new feature that's in progress, probably slated for the 1.2 release in our community. And that's what it looks like. So we put a router in the middle, not a big deal. But the takeaway for our lightning talk is exactly that the fact that OVN Kubernetes uses OVN OVS makes it so much fun, because both for VPCs and any other thing, we're just logically building the blocks. Like Dave was mentioning, we have a UDN, we have a cluster network connect. And then on top of this, we can basically leverage this, and we have more features in the pipeline to make things possible. So extension plug and play is what we're after. And that's it. We have 3 minutes for questions. Thanks, everyone.
Thank you very much. It didn't look like a nightmare so much after all. Are there questions?
UDN.
Yeah, that OCAP actually is close to getting approved with UDN with multiple subnets, because we should not confine ourselves with the notion of subnet that other cloud providers had, right? But in our case, network is the subnet, and network can have multiple siders, because when you carve out thousands of VPCs, it's very hard to reuse the IPs. So we run out of IPs, so we have to start small and grow big. So I would definitely keep that in mind, please.
Do we have more questions?
So when you're using multiple CUDNs in the cluster, they will all still be sharing the same service sider. Pod sider will be separate, I understand.
The service sider is shared for all
There
the
is no thought around
putting a service sider per network.
per-
We are also thinking about that. A lot of people in the community at least think of that natively, because we have a per pod network sider. So why not have a per service sider for each network? Especially with secondary networks, it can get complicated, where in the secondary networks, they might want also to expose the services in addition to just the primary network. It's happening. I mean, I'm not saying it's going to happen, but those questions are arising in the community. But we just went with this opinionated way of doing it for today, where we share it.
Okay.
But with Cluster Network Connect, it also gives you the services, even if it's a shared CIDR range, a point to note that we still isolate it. So if you have a cluster IP in Munich network, another cluster IP in the Berlin network, they still can't talk to each other. So yeah.
Do we have a question?
Just a comment on the connect network part. I think it's cool to see that you're using networking to fix a networking issue.
Thank you, OVN community, for giving us all the logical constructs that makes it possible.
Thank you very much.
Thanks all.